द लास्ट यूनिट ऑफ दिस कोर्स MCS 207 का, ठीक है, ये आखिरी यूनिट है जिसको हम देख लेते हैं। इसमें क्या क्या है? डिस्ट्रीब्यूटेड डेटाबेस, डेटा फ्रेगमेंटेशन एंड रेप्लिकेशन, डिस्ट्रीब्यूटेड क्वेरी प्रोसेसिंग, active databases, XML for data representation, blockchain database, multimedia database, and use of database in web application. Okay, so this is the last unit. Emerging database model. Distributed database simplified. What is it? A distributed database system is a database spread over multiple servers or locations, but it worked as a single logical database. Each site store part of the data and user don't need to know where the data is physically located. So analogy क्या है? Think of a university with a multiple regional centers. Okay? Delhi, Chennai and Noida centers each keep their student data locally. The headquarter has a copy of all data. If a student in Noida wants to check their record, the system fetches it from the nearest appropriate site without the student knowing where the data is stored. Key feature: multiple sites. Each site holds part of the database. Example, Delhi Center has data for Delhi and Noida student. Transparency. Users don't need to know where the data is stored or how it's displayed. Types of transparency. Location transparency. Users can query without knowing the location of data. Replication transparency. User don't see the data is copied at multiple sites. Fragmentation. User don't need to know which part of the data is stored where. Replication. Some data is stored at multiple locations to ensure availability, like Noida student data is at headquarters, Delhi and Noida centers. Fault tolerance. The system can handle more failure than a centralized DBMS because it also manage network issue. High availability. The system is available for longer duration since data is distributed. Scalability. Distributed systems are more scalable than centralized system because adding more sites helps handle more data and users. The quick analogy: distributed DB, university with multiple branches, user student querying data. Transparency: student doesn't need to know which branch holds the data. Replication: copies of the student record at multiple branch. Scalability: university can handle more student and stay open. ठीक है, एक बार हाँ क्या है? A distributed system is a database spread over multiple server and location, but it is a single logical database. Each site store part of the data and user don't need to know where the data is physically stored. Okay, multiple sites. Each site hold parts of database. Transparency: user don't need to know where the data is stored. And replication: some data is stored at the multiple location. Fault: this system can handle more failure than the centralized. The system is available for longer duration since data is distributed. Next, data fragmentation and replication simplified. Fragmentation, what is it? Splitting a database into smaller parts and storing each part at the site it belongs to. Data fragmentation and application के बारे में. Fragmentation, what is it? Splitting a data into a smaller part and storing each part at the site it belongs to. Speed up queries because most requests can be answered using local data. Chennai center store only Chennai students data. Noida center student only Noida student data. Analogy: library system with multiple branch. Each branch keeps only the book relevant to its local student. If a student visits their branch, they can quickly find their book without checking all branches. Replication, what is it? Making copy of data at multiple sites. Making copies of data at multiple sites purpose increase reliability and availability. If one site fails, user can't still access from the another site. Example: Noida student data is stored at the both Noida and Delhi center. Using the library example, replication is like extra copies of popular books at multiple branches of a student can always borrow a copy even if one branch runs out. Key points: fragmentation, splitting data for efficiency. Replication copying data for safety and availability. Distributed query processing simplified version. What is it? In a distributed database, a user submits a query at one site. Distributed query simplified में क्या है? What is it? A distributed database, a user submits a query at one site. The system breaks the query into smaller parts, then combines the result. How it works? Query: find percentage of fee share of Noida. Two sub-queries: total fee collected across all centers, total fee collected from Ranchi, Noida. The system process both sub-queries at headquarters. Process query at Noida, send the result to headquarters to compute the final percentage. Key idea: the system optimizes query execution by considering where the data is stored, cost of moving data, cost of processing the query. Analogy: imagine you are running a school report system. Headquarters wants to know the percentage of students who passed in Noida. Headquarters has overall record, but Noida branch has detailed student info. Instead of sending all data to headquarters, Noida calculates its own total and sends just the result to headquarters. Headquarters then combines it with local student to find the percentage, save the time and reduces unnecessary data transfer. Active database. What is database? Active database automatically perform action when certain event happen. These actions are called triggers in SQL. Example: database has student and result table. Whenever a result is added to grade is updated, the system automatically update the student's CGPA. How it works? Triggering event sometimes happening in database. Example: a new result is entered and grade is changed. Condition: the system checks if the data should run. Only update CGPA is the student status is active. If conditions are satisfied, the actions happen automatically. Issues with active database: managing triggers. Many triggers may exist and old and redundant triggers need to be removed. Performance: a lot of trigger can happen down the database. Analogy देख लेते हैं. Think of an atomic attendance system is school event. A student sweeps their ID card. Only if the student enrolled in the semester, the student automatically makes attendance. Issues: if a student swipes by mistake or a branch student enter incorrectly, the system must handle undoing all those automatic tasks, which can be complicated. XML and data representation simplified. What is XML? XML is extensible markup language, is a way to store represent data using custom tags. Instead of using separate table like a database, all information about an entity can store in a one place. Example from the text: a school has classes, classes have student, and each student have result. In XML it can store like school has classes, classes has student, student have the data. Result, student have result, name, CGPA and result. Attributes: data can also be stored in the attribute text like student enrollment number equal to this. ये जो है attribute हो जा रहा है. Validation DTD. Okay, XML can be validated using DTD, document type definition, which defines the structure. Example: rules from your text. School has one or more classes. Each class has a student. Each student has enroll number, name, program status and result. Querying XML query. XQuery is used to extract data from XML document. Basic keywords for let, where, order, by, return. Real life is school folder, class folder, and this. Blockchain database. What is blockchain? A blockchain is a distributed database where data is stored in block linked together in a sequence. A blockchain is a distributed database where data is stored in block like together in sequence. Each block contains transaction data, a unique number and a hash itself. Because each book contains the previous block has tampering with a block breaks the chain, ensuring security. Components of block number, a unique sequence number, no sense a random number used once to make the block, has unique transaction logs, record of actions, has value a crypt कुछ है. How it works: each block is stored on multiple nodes. Each block is stored on multiple nodes in the network. Transactions are validated using digital signature and consents among nodes. If a block is tampered with, it has changes. Other nodes detect the mismatch, so fraud and corruption is caught immediately. Cryptographic hash function converts any block element into a fixed size unique fingerprint. Small changes in block content produce completely different hashes. Hashing is one way you can generate a hash from data but cannot reverse it to get the data. Validity of transactions ensure the transactions are allowed. For example, A cannot send 500 units if they only have 100. Verified using the ledger and digital signatures. Digital signature: each user has a private, kept secret, and a public. Transactions are signed with a private key and verified with public key. Ensure only authorized user can perform transaction. And real life analogy: imagine a school notebook shared by all students in the class. Each page Each page a block. Each page lists the initial line, assignment, submit, point awarded. Each page has fingerprint of its contents and the fingerprint of the previous page. If someone tries to cheat and change point on page 2, the fingerprint changes and everyone else's notebook shows a mismatch. The class decide together whether change is valid or not. Only the student can correct a signature. Multimedia database. What is multimedia database? It stored different type of data together: text, image, audio, video, and all these. A learning platform stored lecture, query, multimedia data. You might want to search by content using not just by keywords. Find all videos and database integrity. To do this efficiently, the database uses index to create either manually. Characteristics of different multimedia data: textual data, articles, paragraph, heading stored in ASCII or Unicode, searchable using keywords. Images data stored as pixel. Size depends on the color resolution. Indexes by feature like shapes, color, and object. Video animation sequence of frames can be divided into segments representing objects, concepts. Audio data, recorded messages, and sounds can be organized by a voice pattern. Issue of multimedia analysis: must store label index data for meaningful search. Object in images, videos may found hard to recognize. SIFT algorithm help recognize objects in images even if rotated or scaling. Tagging, linking images to people or object, easier search. Auto indexing is hard because audio lacks visual feature. Hardware and I/O requirements: different formats require different devices, scanners, digital cameras, microphones, video cameras, speaker, displays, etc. Real life analogy: books is a text document, photo album is a images, DVDs, the videos, video recording, audio clips. To find a book photo order, use a multi metadata, the content analyze. If a library is well organized, you can quickly find a video about the specific topic or the images. Database in web application simplified. Why database are used in web application? Web application need to store, manage, and retrieve data securely. Feature provided include structure storage, secure insert, update, and delete operations, support for multiple user at the same time, control and fast access to data on a e-commerce website. Registration info is stored. Registration database, cart item, order, product are stored in a separate database. User index via browser, but all the data is fetched and updated from database. How web how web server can connect to database. Web server and database server communicate to store and retrieve data. Step of connection: database driver software to connect, access, credential, username, password, database URL, port. Java web app connecting to MySQL connection. Adding data from form: user fills the form, web server receive, insert data into database, file insert in the database interface. ODBC standard interface to connect to any database. JBC Java specific interface to connect database. Closing connection almost close the database connection after operation. Free resource. Real life analogy: think of a restaurant with a kitchen, database, and a waiter as the web server. Think of a restaurant as a kitchen, okay, which is about all database, and another waiter is about web server. Waiters take orders, user request sends to kitchen. Kitchen prepare foods, waiter deliver food to customer. Order can be taken simultaneously from multiple tables. This is all about this unit 16, emerging database model.